All right, so you're a senior architect, right? You already know that securing your cloud environment is just non-negotiable. So let's skip the buzzwords. Today, we're opening up a tactical playbook. We're going to walk through the exact steps to implement Zero Trust inside your Azure Kubernetes service clusters using Istio, focusing on practical actions you can take like today.
Look, you've done the work. You have the firewalls, the WAFs, maybe even private endpoints. Your fortress has these massive walls. But what happens when somebody's inside? What's to stop a compromised logging service from sniffing around and trying to hit your super-sensitive payments API? That right there, that's the east-west traffic problem, and honestly, it's a huge blind spot in a lot of architectures.
And this is really the heart of the problem, isn't it? A default Kubernetes install is kind of like an office building where every single keycard opens every single door. It's got that soft, chewy center. Any pod in any namespace can try to talk to any other pod. That is not a great security posture, especially when you've got multiple teams and tons of applications all running in the same place.
So, here's our game plan. We'll start with the why. What is this Zero Trust challenge really? Then we'll get into the how, the actual tools Istio gives us. We'll walk through a super safe two-phase rollout, figure out how to debug things when they inevitably go wrong, and then we'll wrap up with a blueprint you can take straight back to your team.
First up, the Zero Trust Challenge. This is all about locking down that internal east-west traffic. We're not treating Zero Trust like some product you just go out and buy. No, think of it as a core architectural principle. It's a total mindset shift that starts with one simple, maybe even scary, assumption. Your internal network is already compromised.
The guiding principle here is super simple. Never trust, always verify. That's it. Every single request between every single microservice has to be authenticated and authorized every single time. In a crazy dynamic cluster where pods are popping up and disappearing all the time, this isn't some nice to have. It's absolutely essential if you want to maintain any kind of real control and security.
Okay, so how do we actually do this with Istio? How do we make it happen? Well, it really boils down to two key tools, two primitives that form the entire foundation of our security strategy.
The best way to think about this is pure authentication. That's all about privacy. It wraps every conversation between your services in this bulletproof layer of encryption so nobody can eavesdrop. Then you have authorization policy. Well, that's the bouncer. It stands at the door with a list and it decides if a service is even allowed to start a conversation in the first place. You've got encryption and you've got permission. You absolutely need both.
Now, let's talk about the rollout. And this is probably the most important part of the whole playbook. Phase 1, permissive mode. The motto here is simple: observe before you enforce. Seriously, if you go straight to enforcement, you're just asking for a production outage. You have to look before you leap.
And the analogy I love for this is to think of permissive mode like installing security cameras before you install the locks on a building. You just watch for a while. You see who's coming and going. You learn the normal patterns of life. Then, and only then, do you write the rules for who gets a key. Strict mode, that's when you actually install the locks and start checking keys at the door.
And you know what? Getting this started is surprisingly simple. It's just one single policy. You apply it to the root namespace of your service mesh, and it basically tells every service, hey, try to use mutual TLS. That's our encrypted, authenticated communication if you can. But if the other side can't, don't worry about it. Just fall back to plain text. It encrypts everything it can, but it blocks absolutely nothing. This is your safety net. It lets you gather all that valuable data without breaking a single app.
Okay, so the cameras are on. We've been watching the traffic logs for, say, a full sprint. We have a really good idea now of who needs to talk to whom. It's time for phase 2. Time to go from just observing to a full-on lockdown by creating and enforcing some strict policies.
So here's what an access rule looks like in practice. This authorization policy says, for any pod with the label app equals payments API, we want to apply an allow rule. Simple enough. But who's allowed? Well, the policy says the source must have a verified identity that comes from the front-end app's namespace. It's explicit, it's targeted, and it's all right there in the code.
And what's so cool is how that chunk of YAML translates directly into something like this, a super clear, human-readable access list. Traffic from front-end apps to our payments API, allowed. But a request from the data analytics namespace, or anywhere else for that matter, denied. Just blocked by default. This is that denial posture we've been talking about, made real.
So now we're ready to flip the switch. We apply this policy just to our backend namespace, and we change one little word. We set the MTLS mode to strict. And what we're telling Istio is, okay,
For this specific namespace, stop being so permissive. Playtime's over. I want you to start enforcing the authorization policies I've created. If a request isn't on the list, you block it. Period.
But look, in the real world, things don't always go perfectly, right? So let's walk through a super common scenario, because knowing how to debug a bad rule is just as important as knowing how to write a good one.
You get this dreaded message on Slack. The checkout service, which is running in your front-end app's namespace, is suddenly getting timeouts, and it's trying to reach the very payments API you just locked down. Your first thought might be, oh no, is it the network? Did something break? But wait, you've got Istio. You have better tools now.
So you turn to Istio's command line tool, Istio tool. You check the logs of the little Envoy proxy that sits right next to your payments API, and boom, right there, clear as day, is your clue. RBAC access denied. This isn't some random network timeout. This is an intentional block by your security policy. Istio is actually doing its job perfectly. The problem is with your rule. So you pull up the policy and there it is, a simple typo. We've all done it. You wrote front end instead of front end apps, a classic, human error. You correct the YAML, you apply it, and just like that, the timeouts are gone. This is such a powerful debugging flow because it takes you directly from the symptom to the root cause in minutes.
Okay, let's zoom back out for a second. We've seen the tools, we've walked through the process for just one namespace. But how do you scale this across your entire organization? You need a blueprint, a repeatable, phased plan that you can use over and over.
The key here, the most crucial point, is that this is an iterative process. You start globally with permissive mode, just watching. Then you pick one low-risk namespace to be your pilot. You write the policies, switch it to strict, and you make sure everything still works. Once that's stable, you just rinse and repeat for the next namespace. This isn't a big bang change. It's methodical, it's safe, and it builds confidence across your whole organization. So, if you only remember 3 things from all this, let it be these. 1. Always start in permissive mode. Observe first, enforce later. 2. Write explicit, targeted authorization policies for each namespace. And 3. Roll out strict mode incrementally, one namespace at a time. This methodical approach is your key to a successful and stress-free implementation.
And that really brings us to the end of our playbook for today. You now have a clear, tactical plan for securing all that internal traffic inside your cluster. But this naturally leads to the next big question. As your cluster grows, managing all of these YAML files by hand just isn't going to scale. So the question I'll leave you with is, how are you going to automate policy management? Are you going to look at GitOps, policy as code frameworks? That's the next exciting step on your zero trust journey.